Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about artisan space technologies. Yes, I have mispronounced it, but artisan, it's a very difficult word for me to pronounce, but it's a company that was started in 2015 and their selling point was they're going to provide low-cost internet to remote location on Earth, like places like Mexico, Alaska, things of that nature. Now, it's one thing to say, is another thing to demonstrate. So to demonstrate, they built their CubeSat, this puppy, that was in DemoSat 2. Now, what was unique about this? Because there are many companies and big daddies like SpaceX, they are doing it. So what is unique about them? Well, they wanted to specifically focus on a remote location, and they were taking a different path. The path was, rather than having dedicated RF equipment, they're going to use SDR, software defined radio. Now, it's a very high quality equipment, but it does have basically it's a multi-tool. It's not built for this frequency, me good, me great for this. It's like it has a lot of leeway. Now, it has both a pro and con. It gives you flexibility, it does take away some efficiency. So generally satellites do not have this, but not all satellites, let that be very clear, not all, but generally it's not preferred. But so they were doing this, and it got a lot of attention, let's just put it that way. How much attention? Well, chump change about around $400 million. So they got a lot of investors really excited about them, and they got their stuff, a lot of money. And then they launched a new concept. The concept is geostationary satellites are big puppies, meaning we have this weird relationship with geostationary, is that low Earth satellite, basically satellite that is in low Earth orbit, is getting smaller and smaller, but geo is getting bigger and bigger. Like, we are going lol in that, and it makes sense. It's like, hey, if you can put solar panel, and solar panel is more efficient, what if you put more solar panel, you get more oomph. So reality is, like, geostationary satellites are huge. That's why satellite launch vehicles that are built for basically low Earth orbit is so small compared to geostationary. Damn. So to give you a context, this is a legacy geostationary satellite. They're going to give it for comparison. That's like, you're talking about around $300 million cost, and you're talking about around 4 to 5 years to build, which is way too fast. I know some of the satellites took 10 years to build, and it's 6.5 ton, big daddy. Now, what they have, micro geo, it's basically low cost, 1 year to build, 420 kilogram, meaning it's half ton, not even one full ton, it's half ton. And there is one penalty is like the footprint goes from, like in this puppy, entire continent to single country. So that's the penalty, but it does work, still is viable. Oh, you're giving coverage to only the full country, oh man, it's like more than good enough. So it's good enough. So that's the idea, and they launched it. It's not just, oh, are we gonna do this? They actually sent it on Falcon Heavy and just yeeted it. It's actually in space. That happened in April 2023. So they have used it, and be mindful, you're like, isn't Falcon Heavy very rarely used? Well, yes, and that's why their next generation of satellites will be using Falcon 9 rather than Falcon Heavy. I'll explain how they can do it. So this is the company. Now, what's the logic behind it? Because be mindful, this time market may feel very saturated. You have Starlink, you have OneWeb, you have Blue Origin going, Hulu, whatever have you. Like, there are so many companies that try. Oh, China is also trying to build one. So we have so many. And why this company want to do something? Like, do they have something unique? Well, yes, they realize something very important. If you can put your satellite to geostationary orbit, problem solved. Yes, latency cannot be solved, but everything else can be solved. Okay, so we have one physical problem that you cannot solve, but everything else can be solved. It's like, okay, would people be willing to put up with that issue? Short answer, absolutely. Imagine living in the middle of nowhere where you don't have internet, where the worst internet you're gonna get is like, oh, the internet is awesome, it's 10 Mbps, but it does have lag. You'll be like, shut up, take money. So they are focusing on geo. Now, geo is a very exclusive club, like seriously, genuinely exclusive club. So there are generally three big daddies that are playing there. So you have national players, basically nations, India, America, things of that nature, nations. Then you have large telecommunication, majority of your television, satellite TV, yeah, some big daddies are coming there. And then we have army budget is not a thing for army, so don't worry about that. So these are generally the three players that are playing around in the geostationary satellite ecospace. For example, this is one of those puppy. That's a human puppy, big daddy. So you see, like, it's huge. Human puppy, satellite. See the context: human, satellite, human, satellite. That's the whole point. Micro geostationary satellite. So the logic is very simple. Like, we have achieved a lot of things, especially because we can miniaturize low Earth orbit satellite, and we have done that. CubeSats have become a thing. They are doing things. So what if we do the things in this puppy rather than just making them as huge as possible? To, like, what if we miniaturize that puppy? So yes, the downscaling will happen. Like, basically, if you are building the best you can build, like this puppy, 4 of this satellite done, whole planet covered. But what if you don't need it? Like, what if you do not have a need for that? What if you only want to cover some countries? What if you want to cover Myanmar? What if you want to cover Philippines? What if you want to cover Mexico? You do not need to take care of the whole continent. You're like, bro, this is the footprint. Done. Good. Go home. So that's what they're doing. And here's the interesting part. I've specified it time and time again. Just because something is built recently does not mean it's built by modern technology, like European launch vehicles. So you have to understand, in satellite is also the same. And because of the cost involved, because of the risk involved, they are very cautious. Like, you would be shocked like how quickly we switched from analog electronics to digital on the planet Earth. We switched like bam. Satellites, surprisingly recently, many satellites were still analog repeaters. Now, of course, best of the best, greatest performance, but still analog. Like, digital is a very recent trend in geostationary, because again, not only these things take years to build, like 5 years, 6 years, or some of them can stretch up to 10 years. You can understand that, like, they would have started it, and by the time they would have launched it, it would have been outdated performance, but outdated performance. So this company, again, that's why they want to always shrink the time from design to actual launch. The closer you can make it, the more recent it becomes. And because they are starting from fresh, everything is built for more flexibility. Rather than giving the biggest performance, it's like flexibility. And the selling point to the customer is satellite broadband. Basically, they're going to give you good internet, but as a backhaul to remote places. They are not targeting giving satellite receiver to every home. That's not their aim. Aim is every place, even places in Myanmar and other backwards communities, especially in Africa. They have mobile phone. They have 5G mobile phone. They just don't have 5G network. What they have is 2G networks. And yes, they actually have 2G networks. And those 2G networks, they do require some fiber backhaul, which they do not have. That's why they do not support very high bandwidth. So they're using microwave backlinks. So what if instead of having microwave backlinks going back and forth, they yeet up there? Now they have a big fat fiber. That is the system, basically satellite. And now that cell tower can actually give, distribute the connection. So that's their aim. They are not targeting like, you get internet, you get internet, you get internet. That's not their target. Can it be done? Yes, you can be done. Like, they are thinking about, like, what if a school wants it? So they can give a school a dedicated line. If cell companies want it, other cell companies want it, you can get it then. It can be done. Again, if you are business, if you have the deep pocket, you should be able to do it. So, but that's not the target. Target is not like, oh, every single household has it. That's not the target. Target is backbone gets it, and we turbocharge the backbone. So that's the logic. So it's kind of unique. They are not even targeting the people same targeted by OneWeb or Starlink. So what about the philosophy? Now, let this be very clear. I have talked time and time again, is that just because you have money and talent does not mean you cannot be successful. What matters is your philosophy. And that's the primary reason why ESA no longer has any rocket that is actually worth launching. The rocket they have, it's so dangerous to them. It's like, yeah, we have to keep increasing the subsidy that we are giving it because it's so useless. And it's like so useless that they are planning 6 iteration of it, and then they're gonna eat it, and then they're gonna, I'm like, have the balls to cut the project. Just don't let this be another SLS. But you get the point. So these people have a different philosophy. The philosophy was, we're gonna build satellites. Okay, so they had the books from LEO satellites, cube satellites, and they did not study the books on geo satellite. They yeeted that. Basically, fresh start. We do not know how to make a geostationary. We will not look up the best practices. We're gonna start fresh, first principle operation. So they have accepted the tolerance of penalty of basically SDR. It is less efficient, but it does give you more flexibility. And why does flexibility matter here? Well, every nation has a different frequency, and every national law has a different bandwidth that can be used. So if you have a fixed antenna, that's awesome. That's efficiency wise, like GG. But sir, we didn't build hardware exactly for this frequency. It's only used in, like, let's say Middle East, or it's only used in Nepal. Yes, that sort of things will happen. So they're like, hey, SDR is like, bro, I got this whole band from here to here, and these slots are here. I can just tune into it. I won't be very efficient, but I will do it. So they are choosing flexibility. Now, satellites are made in just a box. Like, what is a satellite? It's just a box. So what if you treat the box as a cube? What if you took each of the side out of there? So each of the side is spread out. Now what do you have? You have 6 side. So you have 6 panels to work individual. Rather than making a one convoluted piece, you have 6 panels that every individual can work on. So this design, and because each again satellite is not huge and each panel itself is not very huge, now one individual, let's say I'm working, I can have a panel in front of me and I can touch the furthest edge and the closest edge without any issue. I do not need jigs to actually go there or jigs to make that. That makes it cheaper to build, that makes it quicker to build, because as long as human hands can directly reach it, you would be shocked how fast we work. The moment you add jigs and stuff, look into like automobile production, like it's hell of a hassle to deal with it. And again, it's not that it can't be solved, it just requires money. But if you're like, hey, human hand can do this, problem solved. So a satellite is just, rather than built as a complete complex box, is built as a panels, 6 panels, and you're gonna bolt them together. And every panel itself is man portable, meaning they do not need giant cranes. You can see that in satellite manufacturing, where it's like they have huge cranes, jigs that are gonna move things around. They're like, bro, we can just cart it. And sometimes I'm pretty sure most of them, 2 people can just easily eat it wherever they need to. So man portable, man handleable, everything is super cheap. That's the difference between having a building that is like, $40 million versus a building that requires $400 million, especially if you add cranes. So this is one of those things that it allows them to keep the cost down while keeping the flexibility up. On top of the whole system, whole ecosystem is built as an assembly line. It's not built as a, we are building a bespoke thing. We are building a goddamn assembly line. Now, they have a very unique advantage. They are not as bottlenecked as Starlink. Like, wait, why Starlink is bottlenecked? Because they are making thousands of them. So every nut bolt, everything has to go through so much rigorous testing. Whereas like, if you're moving this 1 millimeter, it will, trickle down, like, because again, designing something for mass production, as in like thousands of pieces, is very, very difficult. Designing something that is more of like bespoke, but you only have to make it such a way that you're gonna manufacture, let's say, 50 of them a year. That's much easier. So they do not have the hassle of like only making 1 or 2 satellite a year, and they do not have the limitation of mass production where everything is very constrained. So it's a very unique sweet spot. So anything they will learn, any jig they build, like, hey, what if we build this jig that allows us to rotate and we can work on it, something like that. Like, hey, in this satellite it did not help us, but the next satellite we are building, it will help us. And it won't be like, oh, it creates an issue further down the chain. It's like, hey, eat that out. So it's a very open floor plan kind of scenario there. And they have a very good feedback loop. That's how they achieved it. That's how they went from CubeSat to actually launching a satellite. So that's a very encouraging. And this is the example again, 1.5 meter versus 7.5 meter. So they have achieved it. And this is the ion engine that they are testing. Testing as in like they have actually built it, tested it, and I'm reasonably sure in a few weeks, I think they're going to launch it. So they have learned a lot. And why ion engine here? Well, this is the same thing in opposite direction. So why SpaceX is able to put their satellites in so low Earth orbit? Well, because it's ion engine, and it also gives them as a fail-safe. Fail-safe is if ion engine poofs out, runs out of fuel, or some electrical failure happens, it's gonna crash. It's not gonna create a problem of space debris. That's awesome. Now, geostationary is so far up that you can't actually do anything like that, because again, decelling a geostationary satellite is brutal. You're gonna need a giant rocket just to decel that puppy. So what we have figured out is geostationary. We add some energy to it, not too much, some, and we put it into what we call a graveyard orbit. So these people are like, hey, most of the time satellite only needs gentle correction, but sometimes they need oomph, like long duration oomph. So how do you do that? Like, we generally use peroxide fuel, hypergolic fuels and all that. They do work, they are awesome, but they're big, they're huge. They give you thrust, but what if you added it with something more efficient, like an ion engine? So wouldn't that come with a penalty? Well, yes, ion engine is very slow, but here's the deal. Imagine you launched your satellite on a cheap rocket that only goes to, let's say, Falcon 9, that only takes you to low Earth orbit. Okay, what after that? You use your ion engine to increase your orbit. So you keep doing it. It will take time, but it will allow you to reach higher orbit without changing too much of your payload mass or consuming too much fuel. You reach there. Now you have to do proper fine tuning of location in the orbit. You can use peroxide. And now you have like best of both worlds. So you have the thrust of peroxide and you have basically efficiency of ion. And be mindful, I'm not joking, they actually have a satellite planned, that will be moving around in geostationary. Meaning if military asks them to like, hey, can you cover this location? They move it. Not even joking. Not exaggerated. Of course, it will be slow process, but they can do it. So meaning if a flight carrier group, basically some big daddy is going somewhere, they can literally have a satellite. Oh, we are readjusting the orbit. So when you go there, we're going to have it completely covered, sir. Don't worry about it. So, and it also acts as a very good defense system. Like if your satellite is changing location, it's like, damn. So ion engine is for that long-term space durability. So philosophy is very clever. This is one of the most wise part about them. They are not like, what if we do this? What if we do wisely? Not just like, huh. It's like, it's very good. Now, who are the clients? Because here's the deal. So far, it's just a company. So far, it's just people trying to do stuff. Like that only makes a difference if there are people willing to buy from you. Well, the moment they demonstrated that demo set 2, they got a lot of people's attention, like serious amount of attention, just wabam, attention. You take all the attention you need. So they got a lot of attention, and the first customer was Alaska. Now, Alaska was like, hey, bro, we are here and we are lol in our internet, so please provide us good internet. So they're like, okay, we good, we'll do our best. And the satellite was launched. Unfortunately, basically the people who they bought solar system from, basically the solar panel worked, but apparently the power converters, they yeeted out of there. So it did not work. Satellite went there, launched, opened, telemetry, everything happened, everything worked, and for a few days it did work. But after some time, the solar panel power system poofed out of existence, and yeah, satellite is still alive, it's still working, it just can't do its proper mission. So Alaskans have to wait a bit longer. But be mindful, because of the low cost, if it was done, if this sort of thing happened to any normal geostationary satellite, yeah, lots of money, poof. Here it's like, it's painful, but not unbearable. So even with that, lot of new contracts come in, and that's why I said, like, the company has a unique selling point, and everybody who's looking into it is like, bro, take as much risk as you want. So Peru has already asked them to build system for them. Philippines have asked them to build system. Mexico also have asked them. So all these countries are like paying money. It's like, hey, can you put just one satellite just to cover Mexico, just to cover Philippines, just to cover Peru? So that's why I said that the fact that it does not cover the continent is not an issue. Realistically, it never was an issue. So they're like, we good. So all of these companies have private players who are working with them to give backhaul connections to remote locations, and then from their point they can distribute it however they need to. If they can have communication to hospital, banks, or mobile towers there, whatever have you. So that's the aim here. And here's the deal. These people, private players and all that jazz, they have some money. Then we have daddy money. Daddy money is happening from US Space Force. Now you're like, wait a minute, why the heck Space Force is interested in this puppy? Well, if you look at this animation, this is from China. So as in not from China, as in like USA have realized that China is building way too many naval vessels that are dedicatedly focused on one thing, jam US space asset. That's why they have Space Force. So the idea is that they have built amazing satellites. There is no discussion about it. That's awesome, but here's the deal. What if you jam it? They will go from like completely coverage of everything to so they have learned the hard way that must have redundancy, meaning you must distribute this ability to basically communicate and handle all that jazz with as many players as possible. For you can have your legacy daddy satellites, and you can have baby satellites. And if baby satellite goes poof, daddy satellite goes boom. And if daddy's gets boomed, then this baby's goes boom. So you always have contingencies and fail safe. And why they are focusing so much on this is because of software-defined radio. If you have figured out a frequency, what exact frequency the satellites are using, jamming it is almost easy. Why? Well, they can't do anything about it. But if you have SDR, you do have that inefficiency, but that inefficiency also allows you to yeet against it, meaning US government is providing them the protocols to build a basically far more radiation hardened, far more jamming, basically resistant. Not like, again, there is a limit. You can just yeet 10 megawatts of power there and it's gonna fry the satellite. But within the reasonable restraint, they can make it far more resilient. And be mindful, because of the distance, you really need very high power. Lower satellites are very easy to jam. Basically geostationary, it's so far away that is like difficult, not impossible, difficult. And given the fact that it also has like a very easy way of filtering it out, it's like, bro, relax. So that's why US Space Force is like, bro, shut up, take money, give me this. And they also love the fact that this can easily be relaunched again and again very quickly. So they love that idea. So idea is that they're gonna have a system, they have already SpaceX for quicker response launches, and these people, if let's say China figures out a new way of blocking it, they can easily work into it. Few days, boom, boom, go home. Now, few days part is a bit exaggerated, but that's their aim. That's what they are working towards. It's like they should have the capability. If anybody jams it, anybody booms it, or do anything, we should be able to, have a second launch pronto. Amazon, 24-hour quick delivery in orbit. Now, all these things are fun and good, but there is a sad irony into it, and people have bought into this. That's the ironic part about it, is that fiber is expensive. That people, every Tom, Dick and Harry says, like, fiber is expensive. It's like, no, fiber is not expensive. Fiber is a simple thing. It's not expensive. Neither the transceivers and all that, they are not that expensive. What is expensive is the freaking bureaucracy. It's not like fiber has got way such a bad luck, where it's like for back in the days, early days of phone poles were like very comfortable. They were like, people were just putting it up there. It took government to some time to catch up. Now fiber poles, if you want to do, is like, lol, you have to go through this many regulations. Like, bro, it's fiber. So the bureaucracy attached there, like you can literally have a scenario in India where it's like, sir, those people are not connected. I do not care. You cannot dig here. It's like, nothing is here, sir. Nothing. No, you cannot dig here. You have to go to license from forestry department, and this is like, so much hassle is there, so much bureaucracy is there. So when people say, no, it's millions of dollars per kilometer, it's not the fiber, it's the freaking bureaucracy. That's the tragic part. And because why do we have such bureaucracies is because we do not put it in the same level of importance as roads, power lines, railway link. In India, almost most remote places have railway links, and here still almost all of them have electrical connection. Electronic, as in like they are electrified railway link, 25 kV out of nowhere. They have 25 kV. And Alaska, like they still have roads, they still have power connections. So we do understand that you need power. Like you're gonna put it, like it's gonna be expensive. What does power mean? You have three AC cable, ultra high voltage, then step down to high voltage, then step down to domestic voltage. So if we can do that, why can't we, lay down fiber? It's like, the bureaucracy. That's the whole point. It's like if government, as like let's say a national government sits down and really is like, hey, who is the people who are most capable of reaching everywhere? Well, power company. Which are the other second best people? Road company. Or third best, railway. So if you combine all these three assets that every nation has, you're gonna have fiber on every square inch of the country. So the fact that we don't have it is just like sad. It's just the bureaucracy is really saddening about this. It's like, think about it. It's like countries are going from like, hey, instead of actually laying the fiber, which is will be far more resilient, and you're like, what about earthquakes and this and all that? Yeah, that's true. But here's the deal: you can repair it. Same thing happens with power system, and this will have much greater oomph, much greater throughput. Your satellite can act as a backup. It will be a very good backup, but it will be just a backup, a low latency, high latency backup. But fiber will always provide you the main throughput that is needed. Geostationary satellite cannot even compare to one good fiber. So let alone, and be mindful, if you are designing it properly, it will always have quad link. What does that mean? Each tower is connected to another tower in all four directions. So if any one link gets damaged by earthquakes, landslides and things of that nature, it will damage that area, but it will not isolate the whole network. That's how everything is done. That's how India has fiber. And yes, as a Indians, we are kind of a bit spoiled how good our internet is. Like, I never truly realized until I sat down and calculated the prices of internet compared to every other nation. I'm like, me good. And Geo fiber in India changed everything. Like, we got fiber. Like, heck, I have 300 Mbps up and down, and the capacity is around 3.2 terabytes. So me good. So all these small nations, like Alaska should have that. Come on, Alaska should have that. Like, if you can build a road network, if you can build power network, just ask those two people how to take care of it. It's just remove the red tape. And it's ultra sad for America. If it's inside America happening, that's hyper sad, given the fact that US government had wisdom to understand that these things are important. That shall spend money to get it there, because again, private companies are stuck in this chicken and egg scenario where it's like, hey, we cannot actually bear the cost of fiber because it's too expensive. It will take a lot of time to, return on investment. Government is like, hey, take us, do it, and then run on there. It's like, and private companies were like, so that's the tragic part of it. Fiber is not like, I genuinely find it's like, we have this, right? You do understand we have this. You do understand we have this. Like, if you think fiber is expensive, what do you think is the price of freaking power lines? Or what is the price of railway line? I dare you to look it up. So That's the whole point. And small nations also create a very big paradox for themselves. It's like they are dependent on big nations. There is 200 nations on this planet. Some of them have very good economy, but here's the deal. How many nations have actual space programs? You'll be shocked. It's less than 10. Like some big nations, half of the European nations, they have to rely on each other to actually do it. Like ISRO's capacity is, let me put it this way. If ESA eats UK has nothing. UK has nothing that can even compete against basically ISRO. So let them, Australia, what like they have space program, but what have they launched? Like that's the whole point. It's very frightening that so many small nations can just be dependent on big nations. Like if let's say Peru ever gets into a dispute with America, and let's say they are dependent on this fiber service, US government would be like, hey, you have to do this, and Peru government is like, no, we're not going to do that. They're like, we're going to apply pressure. It's like, no, we will not bow to it. Poof, internet gone. They will bow to it. So that's a very dangerous thing. So that's why having fiber in yourself, you can control it. Having fiber, basically space fiber, they control the satellites. So, and be mindful, that makes you dependent on them for life. Because again, if you start to chip away at that fiber problem, brick by brick, day by day, one state by one state, you're gonna reach a point where you have 100% coverage. Like electrification, that's how it was done. It was not like boom, everybody gets electricity. It was done brick by brick, day by day. Roads, like same thing. Railway, same thing. So fiber should be done in the same way. It is a national priority, but relying on other nations to solve your problem, that's the issue. So, and not to mention, lag of geostationary cannot be solved. Now, is that an issue? Again, for me, again, I'm spoiled. Yeah, for me, it's an issue. But for people who are like, what is internet to like, oh, I'm getting 10 Mbps stable internet. They're like, bro, me good. I do not care. It's like if I'm doing a video call, it's like, hello, can you hear me? Oh, yeah, yeah. So like, they have to talk with pauses. They can deal with this. And big receiver stations, it's like, that's the ironic part of it. That truly saddens me. It's like fiber is not expensive. I'm too tired. Everybody was like, fiber is millions of dollars per kilometer. It's not. It's the freaking bureaucracy. It's like you dig a trench, bury it. Heck, go to remote community, ask them to bury the trench. They will do it for free for you. It's like just the paperwork. Oh my God. So that's the ironic part of it. Like it's easier for us to go build a satellite and actually do it rather than actually, hey, railway company, can you actually help us to just use these poles? And be mindful, these poles are protected by 25 kV, so we do not have to worry about it. Or power lines, it goes through mountains. We have built high voltage lines through mountains, and we are bitching about, oh, fiber is too expensive. It's like, bro, road network, it goes to places that are like, what? And they are maintained. Not only just like a road, they're maintained. And you are genuinely telling me that we can't do fiber? That's the tragic part of it. So this was my presentation on this new company and their unique way of solving a problem. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.